So we're going to look at the crawl space now. So from an air quality standpoint, crawl spaces are important because whatever air is in a crawl space is going to rise through the stack effect and is going to affect the occupants upstairs. So we're looking for signs of moisture and signs of mold. So we're going to go in the crawl space and look at the floor joists, the ceiling surface, and then possibly even some PVC pipe to see if there's actually mold growth on those. So what we're going to be looking for down here, we're going to be using a flashlight at a parallel angle to the floor joist, and we're going to be looking for possible mold growth or dust. And sometimes you can't tell the difference between dust and mold. So if you have a suspicion that it might be mold, then you're going to go ahead and take a tape sample if that's what the customer actually wants to know about. So the way that we take the tape sample is we take the tape off, make a little handle at the end, take some tape. Obviously, we don't want to touch the middle portion of the tape at all, and we're going to be applying this lightly to the wood surface. We could do that on the ceiling as well. And the trick is to not touch the tape, and then we're going to be putting that tape inside a little Ziploc bag for the lab to analyze under microscope. Checking a crawl space is very similar from an air quality standpoint as it is for a home inspection. We're going to be checking to make sure that the soil has been sealed so that we don't have soil gases or soil molds coming to the upstairs through the stack effect. We're also going to be looking on top of pipes to see if we might have some mold growth. That would be an indication that there was too much moisture in the crawl space. And then one thing that we can do, whether it's a crawl space or a basement, is we want to look for signs of previous flooding or water intrusion. And the way that we do that is we're going to look under the stairs at the very bottom, and we'll see possibly some water stains there. And depending on how high those water stains go, it pretty much gives you an indication of how much water might have been in the basement or in the crawl space at some point in time. Another topic for air quality that I want to discuss is flex ducts. Flex ducts are cheap, so they're used commonly for HVAC purposes or for HRVs and ERVs, heat recovery ventilators and energy recovery ventilators. From an air quality standpoint, flex ducts can become a problem within a short period of time after installation. What happens is the dust accumulates in the grooves of this flex duct, and if any kind of humid air is introduced into that duct, we're going to get mold growth. This goes unnoticed, and it can go on for a long time, and it can cause symptoms in the occupants. So if there are symptoms in the household and we're looking to find what the answer is, we definitely want to look at these flex ducts if they exist in the home. So the easiest way to find out if there is an accumulation of mold in the duct is to swab it. And we introduce the swab into the duct and just swab a couple of grooves and pick up some of that dust. Send the swab to the lab to find out if we have an accumulation of mold in that duct. So we're back in the kitchen where I'm going to demonstrate how to take an air sample inside the wall cavity. This would be called a wall check. So for example, if this dishwasher had flooded the floor in the past, the customer may ask, do I have mold in the wall? Do I need to open this wall? And one way that we can find out is take some air samples inside this wall cavity. The way that we do that is we drill a 1/4 inch hole in the drywall, and then we insert this tubing in the wall. Now, wall cavity testing is actually misunderstood and has somewhat of a negative reputation in some circles, but it's actually been very helpful in getting some answers for the customer. The questions that people pose all the time is, well, do we have negatives, or do we have false negatives or false positives? It's hard to get a false positive. I mean, if you have a lot of mold on your slide, the lab says you have a lot of mold. Obviously, there was a lot of mold in the wall. The question is, where was that mold? You might open the wall cavity and find that your bottom plate is perfectly fine, your studs are perfectly fine, so where was this mold? Well, the mold may have been under the bottom plate, or it more than likely was in the insulation. So we try to push the insulation out of the way before we take the sample. but there may still be a lot of mold from the insulation getting onto the slide. A lot of customers don't want mold in their insulation anyway, so it still gives them the answer that they need. So the way that we would do that, and I'm going to show this here because the wall is open, so I will not drill. We're going to introduce the tubing inside the hole that we would have drilled, and then this little black marker here indicates the depth in how far I'm going into the wall. And then I have what I call a dummy cassette here that I'm going to use at first because I'm going to pound on the wall. I want to dislodge some dust there so that I can capture the dust and get that analyzed by the lab. So I'm going to run that for a few seconds, just get rid of the extraneous drywall dust that I've just created by tapping. And then I'm going to go ahead and use my actual cassette. And then I'm going to actually take the sample. This is the sample that will be sent to the lab. And then this would run for the number of minutes that you should run for that particular cassette. This cassette is a micro 5 cassette and it requires a 5-minute air sample. So we would run that for 5 minutes. If you might be using a different kind of cassette and it might be 2 minutes or 3 minutes, just follow the manufacturer's instructions. If, for example, we had flooding upstairs, in the bathroom upstairs, and the ceiling was flooded, the customer may want to know, do I have mold in my ceiling cavity? We would perform the exact same procedure with this tubing and the cassette, but we would do it up in the ceiling cavity. Again, trying to push the insulation out of the way prior to taking your sample. You don't want to block the entry point of the tube. If there is no access to the wall because we cannot drill, for example, if it's a rental property or if it's a pre-purchase inspection, the owner probably doesn't want us to drill. So then the other method would be to use a piece of tape with a knife and trying to slide that knife and tape underneath the bottom plate. And that at least would tell us if mold is present. Maybe not in the wall cavity, but at least under the bottom plate, which would be an indication that flooding had occurred. So this is very low tech, but what we do is we wrap some clear Scotch tape around a very thin knife, and this is the sticky side out. And try not to touch the portion that is going to be analyzed by the lab. I would slide the knife under the bottom plate and try to capture as much dust as I can from the bottom stud and from the floor. And then maybe I'll do it on the other side. And then I'm going to take this piece of tape, which now has a very good sample of dust. I'm going to put it in a plastic Ziploc bag and send that to a lab for analysis. So we've now moved to the bathroom, and from an air quality standpoint, what would we check in the bathroom? Of course, we're going to be looking for moisture in the bathroom. So one thing that we would check would be the moisture content of the area around the tub. The most vulnerable area is going to be near the tub on the edges here, so this bottom plate needs to be checked. The floor would be checked. And then on the other side, again, this is a vulnerable area. If people are showering, the water may seep out of the tub and then onto the floor. And then sometimes we'll even see decay there. There may actually be mold growth in the wall cavity there. The other thing we check for is the caulking all around the tub and make sure that that's not been compromised. If there's leakage going on, if the caulk is missing or it's coming off of the wall, we can have water seepage underneath. And then the way that we would check that would be to go into the plumbing access panel, which would be behind the faucet, and then we can do a visual with a flashlight there. If we see some compromised caulking, we may actually want to do an air sample underneath the tub to rule out a lot of mold growth underneath there. The other thing we're going to check is going to be the vanity. Again, we're going to look for signs of leakage, water stains. If I see stains or if I see signs that there's been some substantial leakage there, I may actually also want to do an air sample underneath this base here at the bottom of the cabinet, between the floor and the bottom of the cabinet, behind the toe kick, just like we did in the kitchen. And then also, finally, I'm going to check around the toilet. I'm going to take some moisture measurement with my meter all around the toilet. Sometimes we have a loose seal or loose toilet. The seal has been broken, and we have some seepage going on, but depending on the type of flooring that they have, we may not be able to see that there's actually water seepage there. We can have quite a bit of decay and mold growth, and nothing is visible on the outside. So we're going to check that with the moisture meter and the infrared camera.